All right, I have to start by apologizing to you. Yesterday I sent you a video with square roots on it and how to find square roots of rational numbers. I kind of jumped the gun. I forgot I had skipped over something very important, and that was negative exponents. Now, you might say, Mr. Do, we learned about that already. Remember, a negative 5 to the third power means a negative 5 times a negative 5 times a negative 5. Well, that's not a negative exponent, that's a negative base number. Today I want to talk about how do you find an answer with a negative exponent. And again, to figure that out, what we have to do is we have to find a pattern. I'm going to ask you to kind of think back a ways to when you were in 5th grade. At the very beginning of 5th grade, we did a card trick. And the purpose of the card trick was for you to figure out a pattern. And again, the only way you can figure out a pattern is to do things in order and then see what's happening in the order they're doing it. By the way, we use that method later to find out what a number to the 0 power equals. And again, you should know a number to 0 power is 1, but you should also know why it's 1. Because if you remember, we would start with things we know like 2 to the first power means the base number is 2, the exponent is 1, we use the 2 one time, it's 2. Any number to the first power is equal to itself. 2 to the second power, the base number is 2, the exponent is 2, means you use the 2 twice in multiplication. 2 times 2 is 4. 2 to the third power, the base number is 3, the base number is 2, the exponent is 3, which means you use the 2 3 times. 2 times 2 is 4, times 2 is 8. And again, we now can find a pattern. A pattern for the exponents, because they went 3, 2, 1, not blast off, but 0. So this would be 2 to the 0 power equals, there's a pattern here too. 8 changes to 4, 4 changes to 2. So mathematically, what's happening at 8 to change it to 4, and the 4 to change it to 2? And the answer is you're taking half of it, or you're dividing by 2. Because you see 8 divided by 2 is 4. 4 divided by 2 is 2. So the pattern is divide by 2. So if you want to find out what 2 to the 0 power was, divide by 2, and the answer is 1. Now you might say, Mr. Do, why are you proving to me what something to the 0 power is equal to? I want to know about negative exponents. And I say, all you have to do is continue the pattern. In other words, 3, 2, 1, 0, the next would be 2 to the negative first. All right? And again, if I continue the pattern here, take half of it, I have to take 1 divided by 2. By the way, you might say, but Mr. Do, 1 divided by 2 is 2. No, 2 divided by 1 is 2. 1 divided by 2 is actually 2 into 1 goes 0 times, remaining 1. It's actually 1/2. And then if I want to continue the pattern, after negative 1 comes 2 to the negative 2. And if I want the answer, I got to take 1/2 and divide it by 2. Now I'm not going to do this. This would be dumb. That's not how we do it. But you take 1/2 divided by 2 over 1, which becomes 1/2 times 1/2, which equals 1/4. And again, if I want to continue the pattern, after negative 2, negative 3 comes. And again, that would be 1/4 divided by 2. And 1/4 divided by 2 over 1 becomes 1/4 times 1/2, which is 1/8. And again, you go, so every time I got to find a negative exponent, I got to list that whole pattern? I go, no. You look at what that pattern tells you. Don't look at what you did get the answer, just look at the problem. You should notice something here. 2 to the first power is 2. 2 to the negative first power is 1/2. 2 to the second power is 4. 2 to the negative second power is 1/4. 2 to the third power is 8. 2 to the negative third power is 1/8. So what are you doing with the negative exponents? You're taking your positive exponent answers and getting the reciprocal. which, by the way, in the algebra book that I used to teach out of, it said this: x to the negative n equals 1 over x to the positive n. And what that's basically saying is that you take the base number and you change it to reciprocal. By the way, if the base number is 1, okay, a is a whole number rather, then 1 over x to the n works. But it might be a little better to think of it as 1 over x to the n. These two things mean the same thing. This will give you the answer in every case, because 1 over x really means the reciprocal of x. Now, for whole numbers, that should not be any problem. So if I had like something like 5 to the negative third power, that would be the same as 1/5 to the positive third power, because you take the exponent and make it positive by making the base number its reciprocal. And reciprocal of 5 is 1/5. By that way, that would be 1/5 times 1/5 times 1/5. And let's get rid of our work here. 1 times 1 times 1 is 1. 5 times 5 is 25. And 25 times 5 is 125. So the answer for 3 to the negative third power is 1/25. Now, if you had a base number, okay, like 2/3 to the negative fourth power, okay, excuse me, I don't really want to make that 1 over 2/3 to the positive fourth power, because 1 over 2/3 means the reciprocal of 2/3. And I could just make the reciprocal of 2/3 3/2 to the fourth power. And 3/2 to the fourth power means 3/2 times 3/2 times 3/2 times 3/2. By the way, 3 times 3 is 9, 3 times 3 is 9, 9 times 9 is 81. 2 times 2 is 4, 2 times 2 is 4, and 4 times 4 is 16. And what's wrong with 81/16? It's improper. So divide 16 into 81 actually goes 5 times with a remainder of 1. So you get 5 and 1/16. I thought I got rid of all of this work. I'll get rid of this work too. So again, if you want to find a negative exponent for a fraction, just change the fraction to its reciprocal. Now what if I had something like this, 1 1/2 squared? Okay, well, to do that, I can't change a mixed numeral into a reciprocal, but I can change a mixed numeral into an improper fraction. And you might say that's the negative half. You might say, but why do I want to make it a fraction? So that since it's a negative exponent, you can change the reciprocal. So this would be 2/3 to the second power, which would mean 2/3 times 2/3, which is 4/9. And again, excuse me, you change the mixed numeral to an improper fraction, and because you have a negative exponent, you change the base number to its reciprocal, and then you make it a positive exponent, and you work it out. So again, whenever you have a fraction or mixed numeral, all you do when you have a negative exponent is change the fraction or the improper fraction into its reciprocal, and then work the problem out. What if I had a decimal? What if I had something like 2/10 to the negative third? Now I'm not going to change this like this. I can't get the reciprocal of a decimal by turning upside down. Matter of fact, I can't get the reciprocal of a decimal at all. But what I can do is I can change the decimal into a fraction, which would be 2/10. I could simplify that fraction, which would be 1/5. And now I can take the negative exponent, is going to mean 1/5 has to change to its reciprocal, which is 5/1, which is just 5 to the third power. And That would mean 5 times 5 times 5. 5 times 5 is 25 times 5. 25 carry a 2, 10 and 2 is 125. So again, if you have a decimal, the first thing you do is change the decimal to a fraction. Then you can change the fraction to its reciprocal in order to make the negative exponent positive. But the key to all negative exponents is make sure you change the base number to its reciprocal and change the exponent to positive. By the way, the last kind I think you'd have to worry about, I don't even know if you have to worry about this, but if you had a negative base number, like a negative 4 to the negative 4th power. Now again, the first thing you would do is you would change a negative 4 into a negative 4 over 1 to the negative 4th power. Then you would change this to its reciprocal, which would be a negative 1/4 to the positive 4th power, which would mean a negative 1/4 times a negative 1/4 times a negative 1/4 times a negative 1/4. By the way, a negative times a negative is a positive times a negative is a negative, and a negative times a negative is a positive. So your answer is going to be positive. 1 times 1 is 1, times 1 is 1, times 1 is 1. 4 times 4 is 16, 4 times 4 is 16, and 16 times 16. 6 times 6 is 36, carry a 3. 6 times 1 is 6, and 3 is 9. 1 times 6 is 6, and 1 times 1 is 1. 6, 9 plus 6 is 15, carry a 1, 2. It's a positive 1/256. By the way, word of warning. Some people think the reason this answer is positive is because a negative times a negative is a positive. But it's important to realize that this negative exponent has nothing to do with the negative base number. The only thing the negative exponent has to do is changing the base number to its reciprocal. All right? So just because these are both negative doesn't make my answer positive. What made my answer positive is this was an even exponent. And remember, we found out if your exponent is even, your answer is going to be positive. And if your exponent is odd, your answer is going to be negative. So if I had a negative 4 to the negative 3rd power, that would be a negative 4 over 1 to the negative 3rd power, which means we would change a negative 4 over 1 to a negative 1/4, and we would change the negative exponent to positive. And that would mean a negative 1/4 times a negative 1/4 times a negative 1/4. Now this time, a negative times a negative is a positive times a negative is a negative, so my answer is negative. 1 times 1 is 1 times 1 is 1, and 4 times 4 is 16, and 16 times 4, 6 times 4 is 24, carry a 2, 4 times 1 is 4, and 2 is 6, and you get a negative 1/64. And again, even though you have a negative exponent and a negative base number, your answer is negative. These have nothing to do with each other. What made the answer negative is the fact that this is an odd number. And remember, an even exponent, the answer is positive. An odd exponent, your answer is negative. But again, the first thing you have to do is take the integer, make it a fraction, and then, because it's a negative exponent, change it to its reciprocal and make it a positive exponent. And that's how you do negative exponents. By the way, I was very impressed. Some of you got 100 on this section, okay, like Ella and Gracie got 100 on this section when I didn't even teach it to you yet. Great job, you did it on your own. And for those of you who couldn't do it yet, I hope with the help of this video, you'll be able to do it. And I apologize that I put them in the wrong order to you. But now you should have enough that you can do all 5 different topics and master them. And I hope everybody gets 500s on all 5 topics.